Welcome to my YouTube channel. Please, if this is your first time watching my video, please check the subscription button and hit it to subscribe for more videos and comment. So now we're going to talk about something in applied electricity. That is the series arrangement of resistors. So now when we talk about the series arrangement of resistors, two or more resistors are said to be in series when they have the same current flowing through each of them. So now in an electric circuit, they have a current flowing through the negative terminal to the positive terminal. So when it flows, if resistors in the current or in the electric circuit have the same current flowing through them, those resistors are said to be in series. Now, let's note this. In order for the current through two or more resistors to be the same, there should be no junction or node. Note this. The definition of a node is any point in an electric circuit where current can divide or add. So, current can divide through that. We call it a junction. See, normally in a junction, we have like three streets coming together. We have a point there. So when you are in a junction, you can either pass through any street you want to pass through. So it's the same application in the series arrangement or in electric circuit. So let's take this question. This is a nice question for us to analyze to see which resistors are in series. But note, before you do this, one thing that you must note about this is now you must divide the current correctly to know where current are flowing through. So now I told that current flowing through the negative terminal to the positive terminal. So when current is passing through this, from here the current will get to this node or junction, it will divide and it will also divide. It divides here. Now when it divides, this will pass through here, this loop, and gets to this place. And this will be the same current passing through this place. So we have the current coming back, and it will come and join this and come to the positive terminal. So let's see the resistors that are in series or are not. So let's see. Now R1 and R2 are in series because there's no node between them. Now without a node itself, you should note that resistors are in series. When resistors are in series, they have the same current. So let's check R1 and R2. This is R1 and R2. Let's see whether they have the same current flowing through them. So when the current flows through this terminal and it's coming here, it passes through this and want to divide and pass here. So this current is passing through this resistor. Now when it passes through the resistor, it also passes through this resistor. So since they have the same current flowing through them, it is said that these resistors are in series because they have the same current flowing through them. Let's check for the next one, which is R5 and R6. Now R5 and R6, when current move from here and flow through this wire, it gets to R6. But you can still know that it will be the same current flowing through R5. Since there's no node here, it will be the same current flowing through it. So they'll have the same current. As we know, for resistors to be in series, they'll have the same current flowing through them. Therefore, R6 and R5 will also be in what? The same current, therefore they are in series. Now let's move. R3 and R4 are in series. Why? When this current move from this place and comes here, it means the current, assuming this is the same, the total current flowing through this resistor, because it will be the total current flowing through R4. Yes. So when it divides, this will come here and rest at this place. This also come and join and pass through this. It means that the total resistor or the total current will also pass through R3, and they will have the same thing in R4. Therefore, R3 and R4 will be the same. They'll have the same current. But let's note this. What is between them is a battery. But you see, what is between them is a battery, but will not cause any current division. Are you getting it? This battery will not cause any current division. But R2 and R5 are not in series, since there's no node between. There's a node between them. So this is R2 and R5. There's no way they'll be in series, since they have different current. Because with series arrangement, they should have the same current flowing through them. Are you getting it? So since they are not having the same current flowing through them, there is no way R2 and R5 will have the same current flowing through them. Let's move on to the parallel arrangement of resistors. Now, when we talk about the parallel arrangement of resistors, that's the vice versa of the series arrangement of resistors. Let me change my color. So with that, I'm going to use this color. So now, with parallel arrangement of resistors, they will have different current flowing through them, but they'll have the same voltage. So with the series, they have the same current but different voltage. With the parallel, they have the same voltage but they'll have different current. Now, it is possible to get resistors which are not in series or parallel. With this, you're going to use delta star. Yeah, we have something called delta and star. That is how to resolve them so that you can get them in series and you solve. So with the delta star, I think I'll drop a video as time goes on. So let's see something. So what you need to know about the parallel is that with the parallel resistors, arrangement of resistors, with them they have the same voltage, but they have different current in them. Are you getting it? So let's take this example. With this, we have a loop. A loop is just a close. I think it's a close. Some that electrical or current flow through them. So we can say that A, B, I, K is a closed circuit. I guess it's a loop. So current flow through them. Now let's check which resistors are in parallel. R4 and R5 are in parallel since there's a node between them. So R4 and R5. Now you know this, you can divide the current for you to note, or for you to know if they don't have the same current flowing through them, therefore they have what? Different current, therefore they will be in what? Parallel. So let's check. So the current flow through here, it divides here and divides here. So it passes through here. I'm talking about R4 and R5. So this is R4 and R5. So when the current gets here, it also divide and pass here, and it's also pass here. This current also will divide and pass here and pass here. Since this current is going to pass through R5 and this is going to pass through R4, they will be in parallel since they have different current flowing through them. Let's check another one. R1 and R2 also are in parallel. Let's check R1. R1 and R2. This is moving here and this is moving here. So you can even notice that they have this different current flowing through them. Let's check. R2 and R3 are not in parallel. Where's R2 and R3? This is R2 and this R3. Since they'll have the same voltage, so they will not be what? Parallel. Sorry, they'll have the same. They can have the same current, which is preventing them from being parallel. Are you getting it? So they'll have the same current. Therefore, there will be no parallel between this series. This resistor, that's R2 and R3, and R3 and R4 too. You can see that the current, when it gets here, it moves. So this and this. Now with this and this, because something, as we know that it is possible to have some resistors which are not in series or parallel. Yes, so it can be neither in series nor parallel. With that one, you're going to use delta star. I get in it. So I will surely drop a video on delta star and how to go about it. Thank you very much for watching this video.